So today we're going to be talking about relevance, which is one of the main things that you're going to assess in your argument analyses. But first, let's talk about some course mechanics, yeah? So for the argument analysis, for example. So they're due November 9th at midnight. That's on the new syllabus. And you're going to submit them via UTOR submit. Yeah? Right. And then sorry, yes, you're right. It's not on the revised syllabus. I had also said that I was going to release the arguments for analysis 2 weeks ahead of time, and I failed to do that. So in the announcements, you're right, it's not on the revised syllabus. On the announcement for the argument analyses, I said it was November 9th. Yeah? Usually people don't complain about you pushing back due dates. If you feel like handing it in on November 6th, by all means. The link is up right now. You could hand it in right now if you wanted. And I think you have most of the skills that you actually need to do the argument analysis already. We're going to add a few more bits of vocabulary and stuff like that. But really, like, you know how to assess the acceptability of premises. You know how to assess their relevance. Like, you know how to assess arguments as a matter of just being a rational person. So, you know what you need to know basically. Really, we're just going to add layers of sort of like complexity onto it. Right? Okay, so you're going to submit via UTOR submit, and you're going to, there's the link to that on Blackboard. If you've never seen UTOR submit before, in the course materials section, there's a link to it. The login that you use is the same user ID and password as your uToronto email address. I take it that everybody should know that. Okay, and the maximum word count is 1,200 words, not including bibliography or title or anything like that. And you don't need to quote the whole editorial that you're talking about. Do say which one you're analyzing, I guess. I mean, it should be obvious from your analysis, but yeah. So 1,200 words is the body of the thing. I just thought I'd point this out. This is from both the revised and the new syllabus, my late policy. So a few people have asked me, can I hand in late assignments? Yes, in general, yes, you can, and under the following conditions. Without authorized extension, they'll be penalized 5% for each calendar date past the deadline. That includes holidays and weekends, and no assignment more than 1 week late will be accepted. That is with the assumed condition that without some kind of documentation of typically medical need. So if you want an extension beyond that, you're going to have to talk to the undergrad philosophy advisor, Anya Jolie. Her email address is, I can send it to you if you want. It's on the UTM philosophy website. She's the one who decides if you get an extension or an accommodation. Okay? That is to keep me from having to decide and to make you mad. She'll make you mad on my behalf. That's nice. It's a good setup. Okay. What else is there? So in terms of format, .doc or .docx formats only. I think UTOR submit actually enforces that, so I put those as rules on what kind of documents can be submitted. Sorry to be Microsoft-centric here. They also made me submit my thesis in .docx format. So this university is like, you know, aligned with the forces of Microsoft. Yeah. So another point that was brought up by somebody's really good question was, am I responsible for the whole article or just the bits you quoted on Blackboard? So one of the articles, I believe I quoted one of the editorials in full. The other one, I only quoted part of it. So you're only responsible for the quoted part, right? Just the part that's up on Blackboard. One of them was just simply too long to deal with the whole thing. So yeah. And just another general tip. When you do your breakdown of the premises, don't just give me block quotes of the sections of the editorial. So I want you to show me that you're able to rephrase, pull out just the relevant parts, focus in on what's important to the argument. Rephrasing also demonstrates to the grader that you understand what you're reading, right? So if you just give me a block quote, that's really not evidence that you understand the content of that. So one of the ways that you give evidence of your understanding is rephrasing appropriately. Yeah? Okay. Good. So those are, you know, the basics of what we'll do for the argument analysis. here are the sections, the subsections that I'd like to see. So I don't want to see one big block of continuous text. There should be subheadings, and these are the subheadings that you should include. So this is not like an essay format. This is not, intro and like describe the, since the dawn of time, man has had arguments and that kind of stuff. We're not interested in that. This is a very sort of rigidly specified exercise, partly to make it easier for you, partly to make it easier to mark. There's better classes to learn in which to learn how to write like an essay style assignment. This is just do these subheadings, and in these subheadings, I want to see the following things. So your premise conclusion breakdown, this is where you will list the premises, your rephrased premises, and the conclusion that you've identified. So that should be very straightforward. That's just the first step of argument mapping that we've been doing all along. Your description of the premise structure. Now, I think I kind of expect you to do an argument map here. If for some reason that you really don't want to do an argument map, you nonetheless have to tell me all of the information that would be in an argument map. That is, which premises are supposed to be evidence for which premises, subconclusions, or the conclusion, are they dependent or independent, and so forth. Okay? So you might as well do the argument map because we're requiring you to give all of the information that would be in it anyway. If you just don't feel like doing the drawing, that's fine. You just give us all the information in text form. That's okay. These should all be in sentence form. Don't give us point form for any of this stuff. I mean, the premise conclusion breakdown should be in premise 1, premise 2, premise 3 form, but everything after that should be either an argument diagram or sentences. Complete sentences, grammatically correct sentences, that kind of thing. And then, so you've given, the first two are really doing argument mapping, the stuff that we've been doing the whole time, and then you're going to go into argument assessment, the stuff that we've just started in on lately. So you're going to tell me about the acceptability of the premises as individual premises. So, you can be brief here. It's okay to say things like, well, this is common sense, everybody accepts this, or I'm not sure about this, but it's not important to the argument. So you can be fairly brief here. But tell me about the acceptability of the premises. Any major interesting features of whether the premises are acceptable or unacceptable. You're going to tell us about the relevance of the premises to subconclusions and the conclusion. We'll talk a little bit more about that today and Thursday. And then you'll sort of summarize how adequate you think the argument is overall, which is really just taking the function of acceptability and relevance. So if it's highly acceptable and highly relevant, the argument is adequate. If it's somewhat acceptable and somewhat relevant, the argument is somewhat adequate, that kind of thing, right? So you're just taking the product of those two things. I mean, it's non-trivial. It's not that there's no work to be done in that section, but really you're just telling me how the last two sections interact to give you like the overall adequacy of the argument. Then you'll consider at least one possible counter-argument. It doesn't have to be devastating. You don't have to overturn the whole thing. You don't even have to endorse your own counter-argument. Just sort of say like, here's something that somebody might say in reply. That kind of thing. Just to show us that you've essentially that you're able to synthesize everything. So the first half of this is really doing analysis. You're breaking the argument down into its parts, telling me about how the parts fit together. And in the end, we want to do a little bit of synthesis. That is, show us that you actually understand how the argument as a whole fits together. Yeah? Okay. And optionally, you can add a bibliography if you want. We don't really expect you to be doing a research project here. We don't really expect you to be digging up a whole bunch of sources. If you find that you want to cite something in order to make your argument, or to formulate your counter-argument, or to say something about acceptability, that's perfectly fine, and we don't really care about the citation style. Like, any of the normal citation styles are fine. Yeah. If you're not already using some kind of citation manager, I strongly recommend it. I use what's called JabRef. You just punch in the data and it formats it for you. There's online sites like EasyBib. EasyBib, you just type in the information and it spits out a well-formatted citation. You can also use Google Scholar. I'll show you that on Thursday. I'll show you how to get a citation out of Google Scholar on Thursday. I don't want to have to try to wrestle with my Wi-Fi right now, but yeah. So totally optional. You don't have to add that. Do include it. If you're drawing on some specific source, do include a reference for it, but you don't need to. probably you can assess these things without adding any additional sources in. And I think last semester, lots of people who got top marks didn't include any additional references. So there's not a strong correlation between adding references and doing very well. Okay? Come in. So yeah, let them in. Okay, and here's the rubric. Here's the way that the marks will be assigned. They're assigned on 5 different categories. And each of them are developed or marked out of 5 for a total of 25 possible points. So clarity of written expression, this is just your overall quality of writing out of 5. That includes things like getting spelling right. It includes things like having grammatical sentences. It also includes things like not having overly elaborate sentences that are way more complex than needed to express the idea that you're expressing. This is one of Grice's maxims of conversation, right? So don't give way more elaborate ways of saying things than are necessary. So those are all, and just a hint in this and every future writing assignment you ever have, typically high school teachers are very impressed by like fancy language. Academics are not. We've swum in the deep waters of fancy language for years and years. It's no longer impressive to us. And if we find you using fancy language and not really getting it right, like there's a million tiny little, like hidden codes on how certain words are used. And if you don't know them very well, you're probably going to use that fancy language a little bit wrong. And that just screams out at somebody who's in this stuff for life, this person doesn't really know how to use this word. So you're much better off taking the simpler language that you're confident in, that you know how to use it. So language that you're confident in, you should never be going to a thesaurus. Basically, don't use a thesaurus. You're just going to use words in a slightly inappropriate way. Yeah. Okay, so that clarity of written expression, all of that is sort of, they're just going to holistically assess the quality of your writing for 1/5 of your mark. Identification of premises and structure, this is basically the first 2 sections. Did you do that in a reasonable way? And with the level of complexity of arguments we're dealing with now, it is very, very likely that there will be more than one legitimate way of breaking down the argument into premises and diagramming the structure of those premises. Okay, so they will have an open mind. They will try to see whether what you put down made sense and all that stuff. Right? Then acceptability and relevance, the next 2 sections. Adequacy and counterargument, the next 2 sections. And then depth of analysis, which is more or less just your, again, it's a holistic assessment of how clearly you understood the structure of the argument. Right? Your ability to both analyze it and synthesize responses. Right? If you're used to sciences, this will be probably very unsatisfying as a rubric. You're like, there's so much room for interpretation. What's going on here? And that is a legitimate problem. It's not a problem that I know how to solve, however. These are ill-defined problems that you're dealing with, meaning the rubric itself has to be somewhat ill-defined. What you don't want is for me to pre-specify one and only one answer, and then mark you on your closeness or farness from that one and only one answer. That would be really bad for you. What you want is for us to leave it a little bit vague, a little bit open, and then in a context-sensitive manner assess how you did individually. So that's the plan. And again, typically, like if you're in sciences, if you get like 85% on a test, that means you got 15% of it wrong. Whereas that's not really how we mark things in the humanities. This is a general feature of how things are marked in the humanities, that if you get over 80%, that's the marker telling you that what they thought you did was excellent. They thought you did really well. If you get over 90%, they thought you did spectacularly. All right? If you get lower than 50%, they were unhappy with your work, and sort of everywhere in between. Yeah? So typically, people don't go below 50% unless they hand in a really not up to par assignment, but also very few people will go over 90%. I think that's a based on past classes, every class that I've ever done in the humanities, the distribution looks somewhat like that. The middle part is variable, lots of room to play in the middle, but yeah, the extremes are pretty regular. Yeah? Okay. So that's the argument analysis. Do not this Thursday, but next Thursday. Good. Test 2, I'm going slow. I probably won't get through all my relevance material, but anyway. So test 2, November 9th, in the usual classroom at the usual time, the usual classroom for Thursday. And here's the structure and basically the content. We're going to have, again, 10 multiple choice questions. 5 of those will be of the same structure as on quiz 2. So on quiz 2, there were 5 questions where I'm like, here's an argument, match it to its argument diagram. There were 5 of those on the quiz. There'll be 5 of those on the test. The other 5 multiple choice questions will be testing your understanding of key course terms, very similar to what we did on test 1. And I will release another list of what I consider to be the key course terms well before the test. Okay? There are going to be 2 definitions style questions, and here's the structure of those questions. I'm going to give you a sentence that's supposed to be a definition, and I'll say, this definition has a problem with it. What do you think the problem is? Identify at least one problem with this definition in the sense of it being too broad or too narrow. Okay? Those are sort of open-ended questions. There'll be 3 fallacy questions. That is, again, I'll give you a sentence, and I'll ask you, is this an instance of this fallacy? Why or why not? And hopefully my approach to fallacies on Thursday gives you a hint about what kind of answers are acceptable here. I don't think that it's always the case that you can say, yes, definitely this is an instance of the fallacy, or no, definitely not. Oftentimes, what you have to say is something more in the middle. You have to say something like, well, it's sort of an instance of this fallacy, and it depends on this or that. Right? So what I want you to understand about these fallacies is what it depends on. What needs to be the case for it to be an instance of the error or an instance of a legitimate argument. Right? So in these questions, I'll say, is this a version of this fallacy? And probably it'll be somewhat clear that it is or isn't, but I need you to explain why. Right? Does that sound reasonable? And there'll be one more argument to diagram. But I won't ask you to assess this argument. You'll just break it down into premises and draw me a diagram. OK? Good. OK. So if there's no further questions, any questions about any of that stuff? Basic course mechanics, argument analysis, test? Good. All right, so let's talk about relevance. So in this class, when we're talking about relevance, what we mean is the relevance of a premise to a conclusion. So relevance in this case is always a relative term. So it's saying, is this premise relevant to establishing that you should believe this subconclusion or this conclusion? And it's relevant to the degree that it does that. It's important to note the difference between this and saying, like, a premise is important or interesting. So if you say something's relevant, oftentimes what you mean is, well, this is something that's got significance or importance or interest or something like that. And that's not exactly what we mean here. What we mean is that it's a good reason to believe the conclusion or subconclusion that it's based on. So the maximum degree of relevance is deductive validity. If an argument is deductive, then the premises are maximally relevant to the conclusion. There's no other facts that you need to know that if the premises are true, then the conclusion must be true. So that's it's a really nice case when it's a deductively valid argument. You can say, well, of course, these premises are relevant completely. Like they hit the maximum degree to which something can be relevant. So when you're dealing with a deductive argument, the way you explain the relevance of the conclusion, or the relevance of the premises to the conclusion, is by citing the argument pattern. So these premises are relevant to the conclusion because they form a modus ponens, right? All spiders are friendly, Gary's a spider, therefore Gary is friendly. When you want to explain how the premises are relevant to the conclusion, you cite the argument pattern. I mean, that's the ideal case. This is a really, really clean case of explaining why these premises are relevant. It's kind of hard to explain why premises are relevant. Sometimes it's just intuitively obvious that it should be, but hard to get under the surface of that intuition. So argument patterns are your tool to get under the surface of your intuitions about relevance. Yeah. So it's a nice case when you can get it, and I mean, this is part of why it helps to rephrase your premises in a way that they become deductively valid arguments, so that you can say, this is how it's supposed to be relevant. The more common case, however, so like we don't get a lot of deductively valid arguments in our lives. Usually what we have are inductive arguments. And so in inductive arguments, the premises lead to the conclusion in a way that is relevant. I mean, if it's a good argument, the premises are relevant to the conclusion, but they don't guarantee the conclusion. So that is, they raise how credible you should find the conclusion, but they don't contain all of the potentially relevant information. So it's sometimes much harder to say exactly how relevant inductive premises are to their conclusions. Again, I think I said this at the beginning of the course. Like, if you could say in general how relevant premises are to conclusions in inductive arguments, you would be finished the scientific method. Like, we would have worked out how to do science entirely. I take it that we haven't quite done that yet. Nonetheless, we have some good ideas about how induction works, right? We have some notions, and I'll give you a couple of inductive argument patterns that you can use to explain the relevance of inductive premises to a conclusion. So those being inductive generalization, inductive syllogism, and inference to the best explanation. So let's do those now. So here's some argument patterns, some inductive argument patterns. And again, these don't guarantee their conclusions, but they should make their conclusions at least more likely. And what you'll see, or what I hope you see, is that the relevance of the premises to the conclusion depends on a lot more. It depends on the background and context in induction, whereas it doesn't depend on background and context in deduction. So here's inductive generalization, one of the inductive argument patterns that you might see. I think this is the most common one. So Z% of observed F's are G. It is probable, therefore, that X% of all F's are G. Okay, so the teal circle is some sample, something that you've observed, right? You've gone out into the world and looked at a few instances, and then you generalize from your sample to some larger population. Yeah? I mean, I take it this is mostly how science works. So a couple of questions that you might ask about an inductive generalization. Is the sample large enough? So you're trying to go from a sample to a population. If I say, I asked 3 random people outside my house what they thought of the Prime Minister, now I know what Canadians think of the Prime Minister. That's probably not a large enough sample, right? You need more than 3 random people. You probably need to sample from like more than one place. If a well-conducted poll surveys 1,000 people to understand Canadian opinions, that's probably a large enough sample. Yeah? I mean, this is so basic that I probably don't need to explain it, but that's one way an inductive generalization can go wrong. The sample was too small. Another way it can go wrong is if the sample is not representative. So I pick on psychology a lot. Psychology has this problem with what's called weird subjects. That is, Western, educated, industrialized, rich, democratic country. People from weird countries are overwhelmingly the subject of psychology research. So the standard way of getting research subjects for a psychology study is force your first and second year psychology undergrads to, for course credit, go do your experiment, which means that almost all psych studies ever done have been done on people in like a really narrow band of age, people from really similar, like I mean, you're wildly different people, but you share a lot just on the basis of having come to a university classroom to take a class. Right? So all of that stuff that you share is being built into the sample that they're using to generalize from. And psychology has started worrying that maybe that wasn't such a hot idea, because if you're trying to make a psychological generalization, the population you're interested in is typically all of humanity. They want to know what's true of humans in general. And they're studying people from 18 to 21 who come from a stable and or lucky enough background, who have made it to university. That means you're really reasonably well educated. You know, like just having gotten here means you've got a decent amount of education. So the sample is weird. And the inference, the inductive generalization they're trying to make from this weird sample to everybody else is questionable. They're working on it. They are working on it, but this has been something they worried about. Similarly, this is an old worry. I think they solved this one, but like it used to be that political polls were done over landlines. For those of you who don't remember, the phone used to be attached to your wall. You could only walk like it was attached to the wall. And old people had these things, whereas young people had cell phones, and they were only calling the landlines. So what you got was statistically like an unrepresentative sample, mostly old people, and in current political climate, old people tend to vote more conservative, so the polls would skew conservative. So their sample was unrepresentative, so the generalizations they were making from it were not good ones. They've since started calling people cell phones, so that they solved this by making the sample more representative. Okay, 2 ways in which inductive generalizations can go wrong. And if you think about examples, I think it should become clear to you that, how big of a sample is big enough? It really depends. When is a sample representative? It depends on a lot of stuff. Like it depends on a lot of stuff other than just the simple premises you're feeding into the argument. Yeah? Okay, now here's the opposite direction of inference when you're going from a population, facts that you know about a population, to facts about a sample. So Z% of F's are G's, where all of F's are G's. X is an F. Therefore, there is a Z% probability that X is G. Okay, so just, it's probably not that clear, but when you say, for example, so here's it going wrong. Here's an attempt at doing this that goes wrong. 53% of Canadians have some post-secondary education. Some of you are Canadians. Therefore, there's a 53% chance that the Canadians in this tutorial have some post-secondary education. Why is that clearly a bad inference? Yeah.
Well, first off, this isn't a tutorial, but
yeah, sorry.
Some sorts of post-secondary education.
That's right.
Is post-secondary education.
Of course, of course. So if you're in, sorry, these are old slides, but yes, if you're in this classroom, you've had some post-secondary education. I saw it happen to you, right? Like we all have had some post-secondary education as of like right now. So 53% of Canadians, if you take a fact about the larger population of Canadians and then try to make an inference about a subpopulation, you can have the exact same representativeness problems as you had in inductive generalization. All right. Here's one that's probably more plausible. Almost every human has caught a cold at some point in their lives. So this is a fact about all humans, right? So almost all of them have had at least one cold. You're a human, presumably true. Therefore, you're very likely to have caught a cold in your life. Yeah? I think that's probably an okay inference, at least for all of you, because you're adults. You've had enough time. So you probably want to exclude things like people like babies. So almost all humans have had a cold. This baby is a human. Therefore, this baby must have had a cold. It's like 1 day old. That doesn't work, right? So it's not always, like with all of these, you don't get to the conclusion with certainty, but with likelihood, right? So it hands up anybody who has never had a cold. Yeah, look, the inference worked, right? So overwhelmingly likely that you've had a cold because almost all humans have had a cold. So we're going from population to sample. Facts about the population to facts about a sample. Here's one that, it's not clear to me that this is actually an inductive syllogism or if this is an analytic statement. Take your pick. It's a really good inference one way or the other. 33% of atoms in a sample of pure H2O at neutral pH are oxygen. This is a sample of pure H2O at neutral pH. Therefore, 33% of the atoms in the sample are oxygen. Now, that's either a really good inductive syllogism because you know that the sample is representative of the population and the population is representative of the sample, kind of stipulated it that way. But maybe it's not even an inductive syllogism. Maybe that's just like, here's what I know about pure samples of H2O at neutral pH. They've got the following constituents. It's just a fact about, it's a definitional analytic fact about about what makes up water, yeah? Okay, good. So that was inductive generalization, where you go from a sample to a population, one argument pattern that you can cite. There's also inductive syllogism, where you go from facts that you know, statistical facts you know about a population, to an inference about what's happening in the sample. Neither one is perfect, but both are perfectly legitimate ways of arguing. Here's another one that should strike you as at least somewhat worrying. Well, all of these should strike you as at least somewhat worried. Don't have zero worry about these. But here's another one that's sort of odd. So inference to the best explanation. If hypothesis H, then observation O. So if my hypothesis is true, then we should observe this. We observed this. Therefore, it's probable that my hypothesis is true. OK, so this is where you say, look, if my theory is right, then this is what we should see. And that's what we saw. So maybe my theory's right. Probably my theory's right. OK. That should remind you of something, though. So this is generally accepted as a reasonable way of arguing, inference to the best explanation. Like the best explanation for what we're seeing is this theory. Therefore, this theory is actually pretty good. What does that argument pattern remind you of, though? Yeah. Affirming the consequent. It's a fallacy. So here's affirming the consequent. If x, then y. Y, therefore x. So, if I had a big lunch, then I'll be sleepy. I'm sleepy, therefore I had a big lunch. Well, if it's 2 a.m., then that's not what happened, is it? Right? OK, so the thing that makes this different, the thing that's supposed to make inference to the best explanation different, is that you kind of help yourself to the following. You kind of go, if x, then y. Maybe if and only if x, then y. But it's not even that strong. Then y. So this is what's called a biconditional, and it's essentially equivalent to if x, then y, and if y, then x. So if you have that, then you can validly infer from y to x, right? So you're just using this half of the biconditional. If y, then x. Y, therefore x. So the inference to the best explanation kind of assumes that there's no other hypotheses on the table, right? That's what's supposed to make it different than the fallacy of affirming the consequent. So, yeah, all that stuff that I just said. Yeah.
So why there's a chance for state kind of?
Well, precisely because you can't, so unless you've ruled out all other possible hypotheses, then it's always possible that somebody will come up with an even better explanation. So inference to the best explanation says, look, this is the best explanation we have of why we're seeing this. Now, unless you can say this is the only possible explanation of why we're seeing this, then it's always possible that somebody has a better explanation, right? Or that a better explanation is possible, and then the observation isn't evidence for your hypothesis. The observation is evidence for that hypothesis. So inference to the best explanation really relies on having one explanation that's far and away better than any of the others on the table, but that's not a guarantee by itself that no other explanation could be generated. But this is a style of argument that actually gets used in serious science. So this was an inference that actually got made. If the theory of general relativity is true, then it follows that light rays passing near the sun will be bent. So if hypothesis, then observation. During the solar eclipse of 1919, it was observed that light rays passing near the sun were deflected. So the gravity of the sun bent the light, and stars showed up where they shouldn't have shown up. Right? So you can, during the eclipse, you can look really close to the sun and see what stars are right beside it. And according to every other physical theory on the table, you should just see normal. The light shouldn't bend at all. It should just be straight. If Einstein was right, the light should be bent. You should see stars that aren't where they're supposed to be. Wait for the eclipse, make the observation. The stars weren't where they're supposed to be. The light was bent in just the way that Einstein said it would be bent. Therefore, it's probable that the theory of general relativity is true. Yeah? And that inference only works because Einstein's theory was the only one making this prediction. It was kind of risky prediction. It was an unlikely prediction. Karl Popper talks about this, how your theory should make predictions that run contrary to common sense that then get confirmed. That's a really good bit of evidence for your theory, right? Yeah?
We could say that affirming the consequent is true when it's kind of a definition.
I don't see how definitions enter into it here.
I mean, like, they're basically saying that the light rays passing near the sun happens because of general relativity, right?
Yeah, so because mass bends space-time, the light should be deflected, yeah. So.
That's the explanation, right?
Yeah, so the theory is an explanation for the observation. It's not clear how that relates to definitions.
Not definition, sorry.
Explanations. Yeah, that's right, that's right. So, yeah, that's right. Inference to the best explanation crucially involves having the best explanation. Yeah, yeah. Okay, so again, like these are all risky inference patterns. You can turn out to have been wrong. Inference to the best explanation is not always right because we are of limited imagination and limited cognitive resources. So like the best explanation as far as you can tell might not be the best, but still, you know, it worked out for general relativity, so it doesn't always fail. All right. But here's one where it fails. If somebody were secretly stealing my money, I'd end up broke. I'm broke. Therefore, probably somebody's secretly stealing my money. Okay. How's that for an inference? It's great, right? Divests me of all responsibility and accountability. I don't have to think about my own actions or like questions like, hey, maybe I didn't make all that much money, and then I spent it. Maybe that's the explanation. Here's an alternative hypothesis for how I ended up broke. I was a grad student for 8 years and liked to go out on weekends, and that's how I ended up broke. That's a pretty good hypothesis. So inference to the best explanation crucially requires that you've ruled out other explanations. Right? So that's what makes the difference between just affirming the consequent. This is affirming the consequent, right? This is a straight up example of the fallacy of affirming the consequent because you haven't ruled out alternative hypotheses. Or at least you haven't shown why this hypothesis is the best one on the table, right? Okay. Good. So, okay, so that was deductive relevance, inductive relevance with just a couple argument patterns. I'd like to talk a little bit about normative relevance because I think that's the hardest case. It's certainly as a subclass of deductive or inductive relevance, right? These are probably not deductive arguments. Remember this argument that we were looking at this weeks and weeks ago where I offered this as like an argument for you to analyze. It's not a good argument, but like an argument that we could analyze. You're not getting any younger and I've got a job, therefore we should get married. And we had this, I thought we had a really interesting discussion about like, are these completely irrelevant premises, or are they just crummy premises? Like, in no way does this rise to the level of being an adequate argument, but are these completely irrelevant, or are they only just minorly relevant? And what's relevant, I hope it came out in that discussion, what's relevant really depends in these normative questions. So look, there's a normative conclusion, we should get married. In normative arguments, what's relevant depends on your whole picture of what it means to be a good human, and what it means to like live a good life, right? So all of your ethical theory is background to determining what's relevant or irrelevant. So if somebody's whole purpose in life is to work as little as possible, be taken care of in material ways as much as possible, and that's it, like you have no other concerns, then these might be relevant premises to you, right? Like, you might at least find the I've got a job one to be relevant. I hope that's not your picture of the good life. That's a pretty like anemic version of what flourishing is, but that's what it depends on, right? Your ethical theory or your values, sort of more specifically. So in general, assessing normative relevance is one of the hardest things that humans do. It's bizarrely difficult to do. I'm glad I get to this. So this is only mostly relevant, but I'd like to, this is my favorite thing I learned during my undergrad, so I tell this story as much as humanly possible. About relevance and about assessing relevance, especially in normative cases, like deciding what you should do. So this is a story from Dan Dennett. Imagine we're trying to design an artificial intelligence. Doing math, doing straight up logic, currently artificial intelligence can do that. If you give it the axioms to work with and a goal to work towards, they're really good at that. But suppose you're trying to build a general artificial intelligence, a robot that can kind of take care of itself without having to be told what to do. Here's our robot, R1D1, and R1D1 runs on batteries. So you put R1D1 into a room with a battery and a bomb on a wagon. And R1D1 makes the following inference. He says, or she says, I need batteries. There's a battery. Therefore, I should take that battery. Right? Like a crucial need of the robot. This action will fulfill that need. Therefore, I should perform that action. It's a good inference, right? It's a good normative inference. So R1D1 pulls the wagon, the bomb goes off and blows it up. Okay, so the designers go back to the drawing board. They say, okay. I know what we did wrong. We just told it to consider the effects of its actions. You can't just consider the effects of your actions. You have to consider the side effects of your actions. Okay, of course. So they retool the robot. They build them up new, R1D1 or D2, where the robot is able to calculate or consider the side effects of its actions as well as its effects. So they shove R1D2 into the room with the battery and the bomb, and it just sits there until the bomb blows up and destroys it. So they go back to the logs and ask, okay, what was it doing when it was just sitting there? Well, R1D2 was doing the following. It was saying, if I pull the wagon, then the battery will come along. If I pull the wagon, then its wheels will turn. If I pull the wagon, then its position relative to Venus will change. If I pull the wagon, then its position relative to that wall will change. If I pull the wagon, and on and on and on. Because the number of side effects of any given action is indefinitely long. I don't want to say infinite, but it's like way too long to calculate them all, right? It's computationally intractable to consider every side effect. So they go back to the drawing. Okay. I got it now. I know what we need to do. We need to tell it to consider the side effects, but to figure out which are the relevant side effects. Of course. So they build, sorry, I messed up the numbers on it. This is R1D2, I guess. So they build them up again. They tell them, okay, you got to sort out what are the relevant side effects. Once again, they push them into the room with the bomb and the battery. Once again, it just stands there until the bomb goes off and blows it up. And when they go through the records, what it's doing is saying, if I pull the wagon, then its wheels will turn. Relevant. If I pull the wagon, its position with respect to Venus will change. Irrelevant. If I pull the wagon, its position with respect to that wall will change. Irrelevant. So it has to go through the whole list still, that intractably long list marking things off as irrelevant. What you need is R2D2 that is able to tell what's relevant without considering all of the possibilities. And that's us, right? We're the machine, the only machines on this planet that are able to sort what's relevant from what's irrelevant without doing this like brute force thing. And the thought experiment is supposed to show that you can't do the brute force thing, right? There's too many side effects to consider, right? There's too many irrelevant things for you to go through them one by one, ticking them all off. You do something vastly more impressive. You intelligently ignore almost everything. Of all of the data available to you and all of the inferences that you could make from it, you intelligently ignore almost all of that. And somehow, without considering it, you home in on the relevant stuff. Somewhat, most of the time. Like, we do a mixed bag of being able to do this, but we're the only things on the planet that can. So the morals of that story, just briefly, working at what is relevant is not likely to be the result of a brute force algorithm. So if you're upset that I can't give you a formula for what's relevant, if I could do that, I would have solved artificial intelligence, and I probably wouldn't be teaching this class. Not that it's not worth my while, but if I knew how to build like a perfect artificial intelligence, I think I'd probably be doing that. I don't, so here we are. So we don't have a general formula which a computer could use for, could execute for figuring out what's relevant. Something about you as a living cognitive agent is required for this to happen. I don't know how we do it, but we all do it. So this is not an argument, to be very clear, this is not an argument that it's impossible to sort relevant from irrelevant, because we all do this every day. It's just an argument for, look, there's not a simple formula for this that we execute. And we do it somehow by intelligently ignoring the vast, vast majority of the information and the possible inferences available to us. It's really stunning that we're capable of doing this. Yeah. And all artificial intelligence currently on the planet operates via the following principle. You tell it ahead of time what's important, what its goals are, and then tell it how close or far it is from the goal on any given learning trial, and then just let it do a bunch of learning trials. So you specify in advance what's relevant and how to measure your distance from the goal, and then it can learn really well. It's either that or a bunch of if-then statements. Like, those are the only types of artificial intelligence we've worked out so far. So while it's still possible to say this, enjoy your cognitive superiority in the realm of determining relevance. And that's my very elaborate excuse for not giving you a nice, neat formula for figuring out how premises are relevant to a conclusion. There really is something deeply human about this that we have not figured out how to formalize. So, okay, so that's it for today. We'll talk more about fallacies of relevance on Thursdays.